Okay, so we have a live audience today, which they will be quiet, but they're back here today, so here we go. Our second special product is the difference of two squares. So the difference of two squares looks like a squared minus b squared. And when you factor it out, it's going to come out looking like a plus b and a minus b. Okay, so here would be an example. You have x squared minus 9, and when you factor that out, it can turn into x plus 3 and x minus 3. So it's going to be really easy if you can just remember this pattern. So there's three questions you want to ask yourself. First of all, are there only two terms? So in this example, there are two terms. Second of all, are both terms perfect squares? So you can see that these are both perfect squares, so those work. And then third, is there a subtraction sign between the two terms because it's called the difference of two squares, so they have to be subtracted. So if the answer to all three of those is yes, you can factor it just like this. Alright, so let's try an example. So, our first question, are there two terms? So we can see clearly that there are two terms. Secondly, are both perfect squares? So in order to see if they're both perfect squares, I see, is there something that I can multiply by itself to then equal my term? And it is 3p. So I know that a is equal to 3p. Now, I look at the 16p squared. Is that a perfect square? And it is. 4p and 4p. Okay, so b is going to be 4p. Now, I should have noticed here that there is a 4p to the fourth, so if I'm going to split this up, it's going to have to be 3p squared and 3p squared. Okay, so are there two terms? Yes. Are they both perfect squares? Yes. Is there a subtraction sign? Yes. Okay, so then I can write it as 3p squared plus 4p and 3p squared minus 4p. So these might kind of remind you of the conjugates because when you multiply them together, they get rid of that middle term just like it did when we multiplied conjugates. So it's a similar concept that the middle terms cancel out and all you have is the first term minus the second term squared. Alright, so one more example. We ask ourselves, is there two terms? Yes, there is. Are they perfect squares? So this could be x to the third times x to the third. However, this one has a 7 in it. So the only factor of 7 is 1 in itself. So therefore, it's not going to work. So it doesn't really matter if there's a subtraction sign or not, because if it's not a perfect square, then it doesn't work, and this actually cannot be factored. There's no common factor. It's not the difference of two squares, so that is the final answer, and it cannot be factored.